A visual inspection shall be performed by the user or designated person each day before the rigging hardware is used. A periodic inspection shall be performed by a designated person, at least annually. The rigging hardware shall be examined and a determination made as to whether they constitute a hazard. Written records are not required. Semi-permanent and inaccessible locations where frequent inspections are not feasible shall have periodic inspections performed. It is important to check all rope for wear and damage before use. Rope can deteriorate due to several factors. These factors include abrasion, fatigue, corrosion, stretching, from overloading and shock loading, and mechanical damage. When inspecting, observe the construction and lay of the rope. Check for signs of stretching. Check the whole rope for broken wires. Where broken wires are present, count the number of broken wires in a length of rope 8 times the rope diameter. The total number of broken wires must not exceed 10% of the total wires. Discard wire rope slings if there is a single broken wire below a metal socket, end fitting, or a machine splice, or if there is abrasion and serious corrosion. Check the valleys between the wires for corrosion beneath the surface. Discard the rope if it has kinks, knots or fractures from bending or reeving, if it has crushed or jammed strands, or bird caging. Do not use the wire if the manufacturer's name or trademark and/or rated load identification is missing or illegible, or if there is a 10% or more reduction of the original dimension. Rope diameters are determined by measuring the circle that just touches the extreme outer limits of the strands. That is, the greatest dimension that can be measured with a pair of parallel-jawed calipers or machinist's caliper square. A mistake could be made by measuring the smaller dimension. The steel wire rope's construction is defined when the following criteria have been determined: the number of wires in a strand, the type of strand, the number of strands, the type of core, the lay direction, and preforming. The steel wire rope is designated according to the number of strands, the number of wires in each strand, the design of the strand, and the type of core. Fiber cores are the most commonly used, as not only do they provide a good, elastic base but also enable lubrication of the rope from the inside, since it is possible to add oil and/or grease to the fiber core during production. This reduces the risk of rust attacking from the inside. The fiber core is normally produced from polypropylene, PP, or sisal. PP can withstand weaker acids and alkalis, and it does not rot. The advantage of a sisal core is that it can absorb oil/grease to a greater degree for lubrication of the steel wire rope from the inside. A steel core is formed as either one of the strands, or as an independent steel wire rope. A steel core increases the steel wire rope's tensile strength by approximately 10%. Chain is heavier than wire rope of the same lifting capacity, but is more durable. It can better withstand rough handling and can be stored without deterioration. Most chain being manufactured today for lifting is grade T or 80 alloy steel. It is stamped T, 800, 80 or 8. It has become the most commonly used chain for lifting in industry. Always check that the grade on the tag matches the grade markings on the chain. Do not use if there is no tag on the chain. Withdraw any chain from service immediately if it has defects. Clearly mark the chain with a tag stating that it must not be used until it has been inspected by the manufacturer. Destroy any chain that cannot be repaired. If the chain is not tagged or properly stamped, it must be removed from service. Enter all inspection details on an inspection record card. Chain assemblies in the maritime industry must be rejected if the testing date is more than 5 years previous. Reject chain assemblies if there is deformation or damage. If there is more than 10% wear on material thickness. If there is excessive rust. If the chain assembly is incomplete according to the certificate, or if the safety latch is broken or missing. Inspect your chain slings regularly. If necessary, clean the chain before inspection. Inspect each link for signs of wear, twisting, stretching, nicks, or gouging. Links that are frozen together show that the chain has been stretched. Find cracks by dusting chain with fine powder. Dust any link that is suspect and then blow the loose particles away. Dust particles will lodge in any cracks, making them more visible. Magnetic particles can also be used. Measure all worn links for the degree of wear. The maximum allowable chain wear is 10%. The maximum allowable elongation of a chain is 10%. The maximum increase in hook opening is 5% of the original throat opening. The maximum allowable wear in the bite of a hook is 10%. Withdraw any chain from service immediately if it has defects. Clearly mark the chain with a tag stating that it must not be used until it has been inspected by the manufacturer. Flat webbing and round synthetic slings are in common use for lifting. They are made from nylon, polyester, polypropylene, or aramid polyamide. Each sling must be labeled with the safe working load. Synthetic slings must be inspected before each use. They must also be inspected by a competent person at least once every 3 months. If a sling is subject to severe conditions, the inspection should be more frequent. When inspecting synthetic slings, look for damage caused by high temperatures, sunlight, or chemicals. This would be indicated by discoloration. Look for damage to the label or stitching. Where the sling is covered by a sleeve, the sleeve must cover the sling for the full length from eye to eye. When inspecting synthetic slings, look for any external wear such as abrasions or cuts and contusions. Internal wear, which is often indicated by a thickening of the sling or the presence of grit and dirt, damage to the eyes or any terminal attachments or end fittings. Reject the sling if the label has been removed or destroyed or there are any visible cuts on the sling. All shackles used for lifting must be stamped with the safe working load. Do not use a shackle that does not have the safe working load marked. Make sure that the safe working load of the shackle is at least as great as the chain, links, and rings in the sling you are using. Do not use a bolt and nut in place of the proper shackle pin. A bolt that does not fit tightly is likely to bend and break. When inspecting shackles, we have to check for body spread, excessive pitting or corrosion, nicks or gouges, indication of heat damage, missing or illegible manufacturer's name or trademark or rated load identification. We have to check for any parts that are worn more than 10% of original dimensions, and any parts that are bent, twisted, distorted, stretched, elongated, or cracked. All pad eyes are to be inspected for cracks or damage prior to each use. The working load limit of any pad eye should not be exceeded. Shackle pins must be allowed to rotate in the shackle pin holes. Use the appropriate size shackle pin and capacity to match the lug hole diameter and capacity. Do not use any undersized shackle pins. All welding should be to the appropriate national standard. Use a qualified welding procedure to weld lug onto equipment. Pad eyes should be welded only onto acceptable base metal, and only onto flat surfaces.